Okay, so in this question here, we've got this mass of 80 kilograms and it's been dragged along, right, a straight line AB. So it's important to recognize here that line, dotted line, the broken line there, AB, okay? And this object is moving along that line, right? It's not going any other direction, it's going along that line, okay? In order to achieve that, you've got all these forces pulling it, right? So you've got a 20 Newton and a T Newton, so pulling in those directions, and you've got 28 pulling in sort of a different direction. All right, but there's a resistance to motion as well, okay? Often resistance is slowing it down, okay? And part A then, we've got to show that T equals 8 root 3, okay? Now, in order to get anywhere near this, we need to sort of resolve in the X direction and the Y direction, okay? But it's important to note this time that the X direction, okay, is in fact the line AB, yeah? So it's important to note that, okay? All right? Okay, so the line AB there will be my X direction, okay? Now, I've got 16 newtons going this way. With this, these different forces here, right, I'll have the T, okay? Obviously, it will have a component in the X direction and the Y direction, so it'll be T. For the X direction here, it'll be T cos 30, won't it? Okay. And for the Y direction, it'll be T sine 30. For the 28, it'll be 28 cos 60. Going in the X, for the X component, and then for the Y component, it'll be 28 sine 60. Okay. And then for this then, the 20, you've got to remember now that the angle is with this line here, okay? So, because it's with the angle is with that line, that's the one that's going to be cos, yeah? So it'll be 20 cos 30 there. And it'll be 20 sine 30 there, okay? Because the angle is there, that's where the cos is. The opposite side, so to speak, will be that line. The opposite, the angle there, the opposite side would be here of the triangle, which... So that means that's the sine value. Okay, now, to show that T equals 8 root 3, we just need to remember something, that it's moving along AB. Okay, so if it's moving along AB, then in the Y direction, we've got equilibrium, we've got a balance. Okay, so these forces here should equal this force here. It will be balanced, okay, because there's no movement in the Y direction. We're going across. So what's pulling it this way, it's got to balance what's pulling it that way. So this direction, we have equilibrium. Okay, so in other words, these two will equal that. Now, if I work this out there, okay, on my calculator, 20 cos 30 will equal 10 root 3. T sine 30, well, sine 30 is a half, and sine 60 is root 3 upon 2. So then I'll have half T equals 28 over 2 is 14. So 14 root 3. Take that 10 over, so I have 10, the 10 root 3 over, so I have that. So then half T will equal 4 root 3, and then take the 2 up, so I have 8 root 3 newtons, exactly as required. Okay, so we're done. So then it says determine the magnitude of the acceleration of the object, right? So it's moving. Now we know that these forces here have no effect on the acceleration of it, because these forces here are perpendicular, okay, to the direction of motion. So if we look at the forces horizontally, okay, acting on the object, we can literally set up an equation, Newton's second law, okay? So we can think of it, if I draw on the force diagram, it might actually help you here to see. Okay, so we've got all these forces going one way, because it's moving in this direction. And then opposing it is the 16 newtons. So using Newton's second law, right, we have all of these. And of course, remember now we know what T is. So we know 8 root 3 for T. Cos 30 plus 28 cos 60 plus 20 sine 30. then take away then the resistant force. So that's my that's my resultant force using Newton's second law, and that will equal to mass, which is 80, times the acceleration, which is what we want to work out. So I'm just going to work out all this stuff here now. Okay, so 80 root 3 cos 30 plus 28 cos 60 plus 20 sine 30 minus 16, and we get 128 exactly equals 80 times A, and then to get A, of course, it's just 128 divided by 80, okay, and I get 8 over 5, okay, or 1.6, exactly, right, 1.6 meters per second, okay, therefore A equals 1.86 meters per second squared. All right, so then it says in part C, right, it says that when the object is moving with speed of 12, the three horizontal forces of 20 newtons, 28 newtons and t newtons are removed. Calculate the time for the speed of the object to reduce to 4. Now, if those forces are removed, the only force that's acting on it is this 16 newtons. Yeah? That's the only force acting on it. Okay? But it's still moving, isn't it, in this direction. So if we use Newton's second law, again in the direction of acceleration, direction of movement, okay, then we'll have, well, there's nothing going in the direction of motion now because all those pulling forces have been removed. We've just got the 16 newtons opposing it, so we take away the 16, and there's no forward force now, they've been all removed. The only force is the resistant force. We have to put minus 16, equals then 80A, so mass times acceleration. So that implies then that the acceleration is minus 16 over 80, so acceleration will be minus 0.2 meters per second squared. Okay, so we've got negative acceleration. It's decelerating, of course. And if we know that it's decelerating at a constant rate, we can then use those conditions for C, and it's saying, look, it's moving at a speed of 12, okay, and then calculate the time it takes for the speed to reduce to 4. Okay, so we want the time there, knowing that the acceleration is minus 0.2. So using V equals U plus AT, so 4 will equal 12 minus 0.2 times T, and then we can get our T from there then. So 0.2T equals 12 minus 4, 0.2T equals 8, okay, and then T will be 8 divided by 0.2, so that will be 40 seconds.